All right, let's talk about time. We all feel it, right? This constant forward flowing river that carries us from one moment to the next. But what if that feeling, that deep intuition, is just completely wrong? Today, we're diving into a really radical idea that time isn't fundamental at all. It's something that, well, emerges from the universe's deepest vibrations.
And it all starts with a question that seems almost childishly simple, but it's one that keeps physicists up at night. Why do you remember yesterday, but not tomorrow? I mean, why does a coffee cup shatter into a million pieces, but you'll never ever see those pieces jump back together to form a perfect cup? This one-way street is what we call the arrow of time. And to really get it, well, we might have to rethink everything.
So, yeah, that common sense view, we all have it. Time is this universal river, right? It just flows, chugging along at the same steady pace for you, for me, for someone on the other side of the planet. It's just there. The constant, invisible background music to our lives. It feels so fundamental, so absolute. But what if that whole picture, our entire concept of time, is just wrong? This new way of thinking suggests our intuition is only scratching the surface of a reality that is much, much deeper and honestly, way more bizarre. A reality where time isn't the backdrop at all. Okay, so let's get into it. To really wrap our heads around this new vision of time, we have to first just completely reset our picture of what reality is. Forget everything you learned about tiny, solid particles, like little billiard balls sitting on some static, empty stage we call space. Instead, imagine this. The universe is a single, unified field. A fabric of reality that's constantly, endlessly vibrating. It's oscillating. And this field, it's not just a backdrop for reality. It is reality, the whole shebang. And here's the crucial bit. Everything we see and touch, from the tiniest little electron to the biggest galaxy, it's not something existing in space. It's just a behavior of space itself. What we call matter, that's just what happens when the vibration of space gets twisted up and locked into a stable knot-like pattern. You're not a vibrating space, so am I. Okay, so if everything, matter included, is just a vibration of space-time, then what on earth is time? It can't be some background ruler that measures what's happening. No, it's gotta be something else, something completely different. And this is where the perspective shift gets really wild. We have to throw out the old view of time as this universal, absolute river. Instead, we see time as something local, something variable. It's not a background dimension we're moving through. It's an actual physical process. It's a rhythm. So in this new picture, time isn't that ruler we move along. It's the actual rhythm, the beat of the local space-time field right where you are. It's the rate at which that local oscillation happens. You could say time is, quite literally, the ticking of space itself. And because this is a physical process, it means time actually has a speed limit. There's a maximum tick rate for reality, called the Planck frequency. It's an insane number, something like 10 to the 43rd ticks per second. And if space-time tries to vibrate any faster than that, the whole thing just collapses into a black hole. Whoa. Okay, so that's a wild idea. But what's really cool is that this new definition of time beautifully explains one of the strangest but absolutely proven facts of physics: time dilation. The idea that time can literally speed up or slow down. And here's how it works. Just think of it like this. Any little patch of space-time has a fixed, finite budget of vibration it can spend. And it has to split that budget between two jobs: moving an object through space and pushing that object forward in time. So what happens when you start moving really, really fast through space? Well, you're literally reallocating that budget. You're essentially stealing some of that vibrational energy away from your own flow of time to pay for your motion through space. And the result? Your local clock, the actual ticking of the space-time you're made of, physically slows down. So this is the really key takeaway. Time dilation, time slowing down, it's not some illusion or a weird mathematical trick. It's a fundamental resource management problem for reality itself. It's basically a law of conservation for space-time's vibration. All right, so this whole framework does a pretty amazing job of explaining why time can bend and stretch. But what about our original question? How does it explain why time has an arrow? Why does it only move forward? Why is the past, well, past? Well, the answer here gets really deep, right down to the very structure of reality. The idea is that space-time is, and this is the key phrase, topologically forbidden from going back to a more orderly state. So it's not just that it's super unlikely, like trying to unshatter a glass, it's that the fundamental rules of the universe's geometry literally forbid the pieces from ever fitting back together in that same perfect way. So the arrow of time, it's simply the ongoing, irreversible breaking apart of spacetime's unified vibration, a process that started at the Big Bang. The universe can keep getting more disordered, more fragmented, but it just cannot, topologically, put itself back together again. The past is gone for good because the very fabric of spacetime has changed in a way that just cannot be undone. It's not a matter of probability. It's not just hard to go backward. It's topologically impossible. There is literally no path in the geometry of the universe back to that previous, less broken state. What's so incredible about this whole framework is that it doesn't just redefine time, it gives us a complete biography of it, a story with a beginning, a middle, and an end, from a dramatic birth to a quiet fading away. So here's the lifespan of time itself. Before the Big Bang, this idea suggests there was this state of perfect, timeless vibration, a global coherence where there was no before or after. The Big Bang, then, wasn't some explosion in space. It was the event, a global phase fracture, that shattered that perfect symmetry, and in doing so, created local time and the arrow of time. And if we look way, way into the distant future, at the so-called heat death of the universe, time will just lose its meaning. Once everything stops and all processes cease, the forward march of time itself will just dissolve away.
So the ultimate takeaway from all this is mind-blowing. Time, this thing that feels so permanent, so fundamental, so eternal, it's actually a temporary and even fragile feature of our universe. It's just a byproduct of a perfect cosmic symmetry that was broken a very, very long time ago.
And that leaves us with one last, pretty provocative thought to chew on. If time, something we all thought was fundamental, turns out to be just an emergent property, what else is? What other parts of our reality that we take for granted, matter, the forces, maybe even space itself, are just the surface of a much deeper and much, much stranger truth?